It's the magic of math here, and today we're going to be subtracting linear expressions where we find the additive inverse, we stack like terms, and we add. Here's our lesson for today. Your objectives today are by the end of this lesson, you will be able to find the additive inverse of a linear expression. You will be able to subtract linear expressions, and you will be able to express differences in simplest form. Here's the question I'd like you thinking about today as I proceed through the lesson. How is subtracting linear expressions different from adding linear expressions, and how is it similar? Let's begin by understanding additive inverses. When we subtract like terms, you add the opposite, or the additive inverse. We will use the same method to subtract linear expressions. So when you learn to add and subtract integers or rational numbers, you learn to add the opposite. So you change subtraction to addition and add the opposite value. An opposite is an additive inverse. We can apply this when we have two expressions. When we have two expressions that have a sum of 0, these expressions are additive inverses. Here's some examples. We're looking for expressions with a sum of 0. So additive inverses, we have 7 and 3x. We want to identify the additive inverse of 7. So to do that, I want to find the opposite. So think of opposite sides of a number line. So 7 is 7 units from 0, so I'm to the right, so I'm going to go to the left. That would be -7. Let's check it. 7 add -7 equals 0. It checks. So 7 and -7 are additive inverses. What do you think the additive inverse is for the variable term 3x? I hope you came up with -3x. Let's check it. When we take 3x and we add -3x, we end up with 0. So it checks. 3x and -3x are additive inverses. You can also note that if you multiply a value by -1, you get the additive inverse. 7 multiplied by -1 is -7. 3x multiplied by -1 is -3x. We're going to apply that idea coming up. First, I want you to do this little task. Your task is to match each linear expression to its additive inverse. So we're given these linear expressions right here, and you're given these answer choices. I'd like you at home to know which one is which. Go ahead and pause the video and come back when you're ready to check your work. Good luck. Welcome back. Let's review our solution. So I'm going to use that little trick. I'm going to take this value and multiply it by -1 to find its matching additive inverse. -4x multiplied by -1 is going to give me +4x. I'm going to take that away and bring it over. -4x and 4x are additive inverses. I'm going to multiply 1/4 x by -1, and I get -1/4 x. Drag and drop it. 6 multiplied by -1, -6. Bring it over. -1/6 x multiplied by -1 is going to give me +1/6 x. Bring it over. And then 6x times -1 will result a product of -6x. Drag and drop. So there you have it. These are all additive inverses. Now let's find the additive inverse of an expression. To find the additive inverse of an expression, we're going to multiply the expression by -1, just like we did to find the additive inverse of those terms. So I'm going to rewrite this so that I can multiply by -1. -1 times the whole linear expression, 3x subtract 8, we're going to multiply by -1 to find the additive inverse. So to do that, I'm going to distribute the -1. -1 multiplied by 3x gives a product of -3x. -1 multiplied by -8 will give me +8. That's the additive inverse of 3x subtract 8. Let's check our work. To check, I'm going to add this with its additive inverse to check to make sure they have a sum of 0. So we start with our original linear expression, 3x subtract 8. We stack our like terms. Negative 3x and 8 is what we came up with for the additive inverse. Now I'm going to add 3x and negative 3x are 0x. Negative 8 and 8 are 0. 0 for my sum. Therefore, I did the correct math. These are additive inverses. All right, your turn. I'd like you to pause the video here, find the additive inverse of 6x subtract 3, come back when you're ready to check your work. Welcome back. Let's review our solution. So again, to find the additive inverse, I'm going to multiply this entire linear expression by negative 1. So I'm going to distribute the negative 1 to each term. Negative 1 multiplied by 6x gives me a product of negative 6x. Negative 1 multiplied by negative 3 gives me a product of positive 3. So my additive inverse of 6x subtract 3 is negative 6x add 3. You can see that each term has an opposite sign. Let's check our work just to be sure. So we're going to stack our original linear expression with what we found for our additive inverse. You can see I've stacked my like terms and I'm going to add 6x and negative 6x are 0x, and negative 3 and 3 are 0. So it checks. All right, now we're going to apply this concept to help us subtract linear expressions. So here, when we are subtracting rational numbers, we learn to add the opposite or the additive inverse. Remember, additive inverse is a math term for finding the opposite. We will use the same process to subtract linear expressions. So it's the same rule you've been doing. First, we will find the additive inverse to rewrite the expression using addition, which we did when we learned to add linear expressions. We rewrote everything as add the opposite or add the additive inverse. So method 1, we're going to use algebra tiles, just like we did for adding linear expression. And method 2, we're going to be stacking like terms. Again, just like we did for adding linear expressions. Same as adding. So there's just one additional step for subtracting. So the difference is that we need to rewrite using the additive inverse. And the thing that's the same is that once it's written as addition, now we're going to use the same methods as when we add. So we're going to find the difference using algebra tiles. So first, my first step when I'm using this method using algebra tiles is to rewrite as addition by finding the additive inverse. So I look at my first linear expression and I'm going to make it 5x add the opposite. Change negative 3 to its additive inverse. We're going to add negative 3. Subtract 3 is the same as add negative 3. We're changing this to addition. In order to change that to addition, I know that I need to multiply each term by negative 1 to find its opposite, because we're going to add the opposite. So I need to find the additive inverse of 2x plus 2. So negative 1 multiplied to 2x is going to give me negative 2x. Negative 1 to positive 2 is going to give me negative 2. We're adding negative 2. All right, let's go ahead and do step 2 is to model the linear expression using algebra tiles. So we're going to take our first term and our second expression. So I'm going to make 5 long x tiles. They're positive, so they're green. 1, 2, 3, 4, 5 x's. And I need 3 integer tiles that are negative. So red ones, 1, 2, and 3. Now let's do our second. Negative 2x is going to be 2 long red ones because it's negative. So 2 negative x's. And then 2 negative integer tiles. So I have 5 x's and 3 negatives, 2 negative x's and 2 negatives. All right, so we are ready to do step 3, which is to remove any 0 pairs. So I see the only ones I have that are 0 pairs are these 2x and negative 2x. So I can remove those from my workspace. Now I don't have any remaining opposites. And I'm going to do step 4, which is to write a linear expression that represents the remaining algebra tiles. So I see I have 3 x's and 5 negative integer tiles. So 3x subtract 5. All right, now it's your turn. I've left the steps here for you to see. I'd like you to draw out how you're going to solve this using algebra tiles. Follow each step just like I did. Come back when you're ready to see my work. Welcome back. So first we're going to rewrite this as addition. Negative 2x, add, change this to add, and the opposite of 3 is negative 3. We're going to find the additive inverse or opposite of the second linear expression. So we're going to know that there's a negative 1 there, right? There's an invisible 1. So I've switched this to add, and now I've got to do the opposite of each term inside, which is the same as multiplying by negative 1. So negative 1 multiplied by 5x gives me negative 5x. Negative 1 multiplied to negative 4 is going to give me positive 4. So I'm going to bring my expressions down. We need 2 negative x's, so 2 long reds. And then negative 3, we need 3 red integer tiles. And over here, I need 5 negative x's, so 5 long negative x's that are red. And then I need 4 positive, so 4 green integer tiles. 1, 2, 3, and 4. Now I'm looking for step 3, which is to remove any 0 pairs. So these are all the same, they're not opposite, but I see I have 3 negative integer chips and 3 positive. So I can identify that those are 0 pairs and remove them from my workspace. Now I'm going to write a linear expression that represents what's left. I have 7 negative x tiles, so that's negative 7x, and then 1 positive integer tile. Negative 7x and 1 is the difference when I subtracted. All right, now let's look at doing this the second method by stacking. So method 2, stacking like terms, just like we did with adding linear expressions, we're first going to rewrite as addition. So when we do this, we're going to do 7x, change to addition, and add the opposite of 6, which is negative 6. And then I'm going to change this subtract to add, remembering I have my negative 1 that I'm going to multiply to each term to get my additive inverse. Negative 1 multiplied by 4x is negative 4x. Negative 1 multiplied by positive 3 is negative 3. Now I'm going to stack like terms in columns. So 7x add negative 6, and my negative 4x add negative 3. So I have my step 3 now, where I'm going to add my like terms and simplify if necessary. So I have my variable terms and my constant terms. 7x and negative 4x are 3x. Negative 6 and negative 3 are negative 9. And now 3x add negative 9 in its simplest form is 3x subtract 9. Remember, we can change subtract to add and add the opposite. So when we answer, I would accept this as your teacher, but we need to recognize that these are the same. All right, your turn. I left you all the steps right here. You're going to use these steps to stack like terms to subtract. Go ahead and pause here. Come back when you're done. Welcome back. So first we're going to rewrite using addition. So we have negative 4x add negative 9. Then we have our invisible 1. So we're going to change the subtract to add and add the additive inverse. So negative 1 multiplied by 2x is going to give me negative 2x. Negative 1 multiplied to positive 6 is going to give me negative 6. So let's stack our first expression, negative 4x, add negative 9. Then underneath, negative 2x and a negative 6. So I have my stacked variable terms and my stacked constants. Negative 4x and negative 2x are negative 6x. Negative 9 and negative 6 are negative 15. And now I'm ready to rewrite negative 6 subtract 15 is the difference when I subtract. All right, let's do this with fractions. Same concept, same steps. So I'm going to first rewrite with addition. So I'm going to do that by understanding my first expression has no subtraction, so I'm just going to leave it the way it is. I'm going to change this subtract to add and recognize that I have that invisible 1. So I'm going to multiply each term inside by -1, which gives me -1 multiplied by 3/4 x is going to be -3/4 x. -1 multiplied to -1/6 is going to give me +1/6. Now we're going to stack our terms, 1/2 x and 2/3, -3/4 x and 1/6. So I can see I have my variable terms, but I can't add them because they don't have the same denominator. I need a common denominator. So I can see I have 2 and 4. My common denominator here would be 4. So I'm going to multiply the numerator and the denominator of this fraction both by 2 to get a common denominator of 4. So that would give me 2/4. So when I do that, I get 2/4 x all over -3/4 x. Then when I look at my constant terms, I see they don't have a common denominator either. So my common denominator between 3 and 6 would be 6. In order for this to have a denominator of 6, I need to multiply both the numerator and denominator by 2. 2 times 2 is 4 over 6, and then 1/6 stays. And I'm ready to add. I have my like variable terms and my like constants. 2/4 x and -3/4 x are going to give me -1/4 x. 4/6 add 1/6 is going to give me +5/6. And there you have our difference, -1/4 x add 5/6. Your turn. Go ahead and pause the video here, subtract, come back when you're ready to check your work. Welcome back. So I'm going to rewrite as addition. So 4/9 x add -5/6. 4/9 x add the opposite, add -5/6 x. I've already changed my subtraction to addition, which means I got to find the additive inverse of each term inside. So we're going to distribute our -1. -1 multiplied by +1/3 x is going to give me -1/3 x. -1 multiplied to -1/2 is going to give me +1/2. Now let's stack our expressions, and we're ready to add. When I go to add, I see that we do not have a common denominator here. Here, I'm going to use a common denominator of 9, which means I need to multiply each numerator and denominator here by 3. So that would become 3/9. So let's go get that set up. We have 4/9 x and -3/9 x. In my constants, I see that I have unlike denominators. My common denominator here would be 6. So I'm going to multiply the numerator and denominator here each by 3 to force that common denominator. Let's bring our add -5/6 here, and then multiply by 3 will give me 3/6. And we're ready to add. Here are my variable terms and my constant terms. 4/9 x add -3/9 x gives me 1/9 x. -5/6 add 3/6 has a sum of -2/6. This can be simplified. So I'm going to rewrite this as subtract. So I'm going to do 1/9 x, subtract, and 2/6 simplifies to 1/3. These are equivalent expressions. Let's see what this looks like in the real world. We have two friends that take rideshare trips from the same location. Leah's distance traveled is represented by 3x plus 1.2 miles. Andre's distance is represented by 5x plus 0.4 miles. And we're asked to write an expression to represent how many fewer miles Leah traveled compared to Andre. So we want to know she traveled less, Leah did. So we want to start with what Andre did, and if we take away what Leah did, we can see how many fewer miles, because we know that Andre went further. So when we subtract, we're going to rewrite as addition first. So there's no addition here. Change this subtraction to addition, and we're going to find the additive inverse of the second expression. -1 multiplied by 3x is -3x. -1 multiplied by +1.2 is -1.2. Let's stack our expressions to stack our like terms. and we're going to add. We have our variable terms and our constant terms. 5x and negative 3x are 2x. 0.4 and negative 1.2. Well, I know that it's going to be negative because my larger absolute value is negative. So if I look at taking the 0.4 away, I know I'm going to have negative 0.8. Rewriting that, 2x subtract 0.8 miles is how many fewer Leah did. So if I add this value to Leah, it will equal Andre. All right, it's your turn. We have 2 users that track their weekly streaming time. Maya streams 2.4x plus 5 hours, and Jordan streams 1.8x and 6.5 hours. I want you to write an expression for how many more hours Maya streamed than Jordan. Here's where you pause, do your best work, and then come back to see mine. Good luck. Welcome back. Here's our solution. So we want to understand that Maya did 2.4x plus 5 hours. Jordan did 1.8x plus 6.5, and we're asked to find how many more hours Maya streamed. So we're going to take Maya's streaming hours, subtract Jordan's streaming hours, and we'll know the difference. So we're going to rewrite using addition. So this is no subtraction here, it's already all addition. Change that subtract to add, and we're going to find the additive inverse by distributing negative 1. Negative 1 times 1.8x is going to give me negative 1.8x. Negative 1 multiplied by positive 6.5 gives me negative 6.5. Let's stack our expressions so that we have our like terms stacked. And we see that we have 2.4x and negative 1.8x. I have 2/10 here and an extra 4 there, so 0.6x. And then 5 and negative 6.5, I know it's going to be negative because my larger absolute value is negative. And I'm going to take 5 away from that, giving me negative 1.5 less. And we're going to rewrite that using a subtraction. 0.6x subtract 1.5 hours would be how many more hours Maya streamed than Jordan. And there you have it. That's the magic of math, where we master math one video at a time. Thanks for joining me today. I hope you come back soon.